Welcome to the topic Combustion and Flame. What do a birthday candle, an LPG stove, and a forest fire have in common? All three involve the same chemical process, combustion, just happening at different speeds and scales. This chapter answers four big questions: what exactly is burning, chemically speaking? What three things must be present for anything to catch fire? Why does a candle flame have different colors in different parts? What makes one fuel better than the another? What is the environmental cost of burning fuels? Today, we are following the NCERT Class 8 Science Chapter 6 sequence exactly so it can be used alongside the textbook for classroom teaching, revision, or exam preparation. So, here I want to give you a minute to read through these learning objectives before I start. This is the checklist for the chapter. By the end of the class, every student should be able to understand each of these objectives. I hope you are done. Let's move on. What's combustion? Combustion is nothing but a chemical process which a substance reacts with oxygen, giving off heat and light. I particularly want to stress on two words here: chemical and oxygen. Combustion is not just something getting hot. Physical heating like kettle on an induction plate is not combustion because and no new chemical substance is formed and no reaction with oxygen. Go through two examples. Example 1: magnesium plus oxygen gives rise to magnesium oxide. So here the supporter of combustion is oxygen and the product is magnesium oxide, which is in white color. I hope most of you burned magnesium ribbon during Diwali. Second example is methane, CH4, the main component of LPG and natural gas or biogas, shows that combustion of fuels containing carbon and hydrogen produces carbon dioxide and water vapor. This becomes important later when we discuss global warming. And a few students have a misconception that rusting is also a combustion process. No, because rusting is only an oxidation reaction. But whereas this combustion reaction should have rapid oxidation and also visible heat or light. Okay, and mostly the combustion reactions are exothermic reactions or are highly exothermic reactions. All combustion reactions are exothermic reactions. That means it gives lot of light and heat. Here we have three types of combustions. They are rapid, spontaneous and explosion. Rapid. The everyday case student already knows the gas stove. What do you do to start it? Yes, you need to turn on the knob and give it a spark. And what about the spontaneous? Spontaneous means without giving the spark, the substance catches the fire. Example: white phosphorus is stored under water specifically because it ignites spontaneously in air. And this is why matchstick factories historically had fire risks from stored phosphorus and why heaps of coal or cotton waste are known as industrial fire hazard. And the third case is explosion, the fastest and the most dangerous case. Combustion that happens so quickly that gas expansion produces a shock wave, sound plus blast. LPG gas cylinder safety. A leak that mixes with the air and finds a spark can explode. This is exactly why LPG is given a foul smell deliberately, so leaks are noticed before they reach explosive concentration. Okay. Now don't get confused between the explosion and rapid combustion. Rapid combustion is fast, but it does not have the sound or large gas involved. But whereas this explosion is very sudden and there is a large sound or gas in the output. And rapid combustion is steady and controlled. What are the important conditions required for combustion to occur? Here you can observe there is a fire triangle given, and you need to observe that to make a triangle we need three sides. In a similar way here, fuel, oxygen or air and heat are needed to make combustion. So here let us try to learn about each thing. Fuel is needed to burn anything, okay, that can burn anything. And air or oxygen, bottom left, without an oxidizer no combustion occurs even with fuel and heat present. Heat or ignition. Every fuel needs to be raised to its own minimum temperature before it ignites. Striking a matchstick provides this initial heat. So to stop fire, you need to remove any one side. Okay. This single idea explains every firefighting method in the next two slides. Okay. Water removes heat and a fire blanket or carbon dioxide removes air, and fuel, like removing trees from the forest fire, clearing the trees from the forest fire removes the fuel. So do you know why does a blowing out a candle work? How does it work? Do you know? When you blow the candle, it removes the supply of hot wax vapor fuel near the wick and disperses heat, dropping the local temperature below ignition point, and then you can stop the fire. Here, let us learn more about the ignition temperature and inflammable substances. Ignition temperature is the lowest temperature at which a substance catches fire. It is property of a substance, not a fixed universal number. Every fuel has its own ignition temperature. Wood and paper need a flame held to them for a while before they catch fire because of their ignition temperature. While not extremely high, it's enough that ambient heat will never reach it. Whereas petrol, alcohol and LPG have low ignition temperature that even a small spark is enough for them to catch fire. So, do you also know that the CNG fuel vehicles and petrol diesel vehicles differ this safety designs? Do you know that? Can you give me an examples of can you give me an example of combustible and non-combustible substances? Okay, so check on the list here. Here you should observe that we have written iron, gold and most metals at room temperature. So here I am considering these substances as non-combustible at room temperature. I am labeling them as non-combustible at room temperature. But when you heat it with very high temperatures, even they are also combustible. Understood? For example, iron, for instance, can burn in pure oxygen at high temperature. This is how some industrial cutting torches work. And even water can be split and its hydrogen can be burned. Okay. Now, how do we control fire? As I told you already, we need three things to control. We need three things to make fire. They are fuel, oxygen, and also the temperature or the amount of heat. And in the similar way I told you, we need to remove one side of a triangle to put off the fire. Either you can cut off fuel or cut off air or lower the ignition temperature. So let us discuss more in detail. Method 1. Cut off fuel, used at large scale in forest fire control, and is also why we keep flammable stores away from ignition sources. Second method, cut off air. So here I think most of you have observed, if there is a fire on the gas cylinder or a stove, then what do? They just cover it with a damp cloth. Okay, because it stops oxygen reaching the burning surface, and also you can use carbon dioxide fire extinguishers. And the third method is lower temperature. So here for lowering temperature mostly water is used, but in few cases you shouldn't use water. I'll tell you in detail. Water is the most familiar agent, but water is not safe for every fire type. Examples like electrical fires, because water is an good conductor. You cannot use water on electric fires, and also you cannot use water on oil or petrol fires, because oil floats on water and water can splash and spread burning oil over a large area instead of putting it out. So this is the reason we cannot use the same method for every fire. So I hope everybody understood. We have different types of fire extinguishers. So first one, water. What does it do? It removes heat, and it is best used for wood, paper, cloth fires, and you should avoid on electrical or oil fires. Next one, carbon dioxide. You can remove air or oxygen, and mostly it is used on electric fires and inflammable liquids. Next one, foam type is also the same way. It can be used in the oil or petrol fires. Soda acid combines and forms carbon dioxide and with water to deliver both cooling and smothering effect. Generally it is used for household fires. So you should understand here that carbon dioxide is used as a fire extinguisher. Okay, and why? Because carbon dioxide is heavier than air, and this carbon dioxide sinks and forms a blanket over the burning material, displacing the lighter oxygen containing air away from the fuel surface, starving the fire of oxygen. Okay, you should never throw water on an electric appliance if it catches fire. Okay, you should only use carbon dioxide, or if it is possible you should cut off the power. Okay, next, so let us discuss deep about the structure of the flame. This is very important, children, and the diagram is also very important. Please practice the diagram. A candle flame has three zones. Okay, dark zone, luminous zone, and non-luminous zone. So first one is the dark zone, that is the innermost one. Okay, this is unburnt vaporized wax that hasn't yet mixed with enough oxygen to burn. It looks dark or black because no combustion light is being emitted here. It is the least hot of three zones. Okay, and zone 2 is middle or luminous zone. Here, the wax vapor undergoes incomplete combustion due to a limited oxygen supply. Unburnt carbon particles heat up and glow, producing the flame's familiar bright yellow light. This is moderately hot, and this is the zone that deposits soot on a cold plate held in the flame. If you want, you can hold a spoon and keep it in the second zone, that is luminous zone. Then you can observe that black soot is formed on the spoon. Non-luminous or outer zone. Here there is a plenty of oxygen, so combustion is complete. The flame is nearly invisible or pale blue. Okay, this is the hottest zone of all the three. Did you ever get chance to visit goldsmith? Goldsmith traditionally hold the metal in the outer zone to melt it efficiently. Okay, so tell me now, which zone is the hottest? Outer zone or non-luminous zone? Very good. So here let us talk about the fuels and the ideal fuel. Okay, which fuel is real and perfect? Yes, we don't have any perfect fuel, but we do use based on their properties. Okay, so here what are the characteristics of an ideal fuel? It should have high calorific value, whereas this wood does not have high calorific value, it has low calorific value, okay, when compared to the LPG. Then it should have moderate ignition temperature, not too low, not too high, okay, and steady burning rate. This is why LPG cylinders use a regulator or valve. It's not just about having fuel, but about controlling how fast it burns. And it should also have little or no ash. Wood or coal leave significant ash residue that must be cleared. Okay, but this LPG and CNG leave essentially none, which is one reason they are preferred for modern cooking and vehicles. Few harmful gases. Yes, we do have few harmful effects of burning fuels. Let us check later in the text. No single fuel ticks every box perfectly. That is the reason choosing a fuel is always a trade-off between cost, safety, availability, and environmental impact. Okay. So now let us learn about the calorific value carefully. What is calorific value? The amount of heat energy produced on complete combustion of 1 kilogram of a fuel is called calorific value, and it is measured in kilojoules per kilograms. Here you can see there is a graph showing calorific values of cow dung, cake, wood, coal, biogas, petrol, kerosene, LPG and hydrogen. So when you look at this graph, you can understand that cow dung, cake and wood are traditional biomass fuels with comparatively low calorific value, which is a part of why so much firewood or dung is needed to cook a meal compared to the small LPG cylinder. Coal sits in the middle. Petrol, kerosene, LPG are high-grade fossil fuels. Hydrogen has an exceptionally higher calorific value. Its true value is roughly 3 times that of LPG, which is exactly why it is used as a rocket fuel. And I think you people now understood why households have largely shifted from wood, cow dung, cakes to LPG over the recent decades. But maybe few are still were not able to afford it. That is the reason few in the tribal areas or uh, in some groups you may find still cooked wood and cow dung cakes are used for as a cooking fuel. Next one is choosing the right fuel. As I discussed already, you need to choose right fuel for different purpose. So for cooking, as we already understood that LPG wins on cleanliness, controllability and low ash, and not only purely on calorific value. Okay, so here next for vehicles, what is the best fuel? Energy needs to be packed into small tanks. That is the reason fuel's calorific value and density matters for vehicles. So what about the rockets? Yes, so for rockets, the mass is the enemy of a rocket. So hydrogen has a huge calorific value per kg and is decisive even though it's bulky as gas. It is stored as liquid hydrogen, cooled to extremely low temperatures and used. Okay. And what about the rural household? This row is important for empathy and real world awareness. So, cost and local availability can outweigh the efficiency for many households. Even though this comes at cost of more smoke exposure and indoor air pollution, they may choose to use this wood or cow dung cakes. I told you these all things have harmful effects. Burning of all these types of fuels have harmful effects. Let us learn about the harmful effects of burning fuels. Carbon monoxide poisoning. So, one of the most poisonous gas when fuel is burned, the carbon monoxide is formed, and this carbon monoxide when we breathe and if it enters inside, it mixes with hemoglobin about 200 times more than the oxygen, and it doesn't allow the oxygen uh, to be taken inside. So what happens? Finally it will lead to death. Okay, and you should also understand here, carbon monoxide is colorless and odorless. This is precisely why a running car engine generator or a charcoal or coal stove in a closed room or garage is extremely dangerous and has caused real deaths. Always ensure ventilation when using any flame or engine indoors. So next is respiratory illness. Yes, incomplete combustion causes soot. You already learned that, yes or no? And this soot or smoky, poorly maintained stoves and like smoke from the vehicle engines, all these things are causes a respiratory illness or respiratory diseases like asthma. Next one is acid rain. Here, acid rains when sulfur dioxide combines with water vapor, it forms acid rain, and it corroses the historic monuments and buildings. You know, right? Taj Mahal should be protected. But if this pollution increases, there will be this acid rains, and even they damage the soil fertility and freshwater ecosystems. Global warming. As discussed earlier, when I was discussing about methane, when burning methane in presence of oxygen, what happens? It is converted into carbon dioxide and water and heat. Yes or no? So what happens? This carbon dioxide is comes as a byproduct, not just as a pollution, but as an unavoidable consequence of the chemistry itself. Reducing emissions, therefore, means reducing how much carbon fuel we burn, not just cleaning up the burning process. So, here, to reduce the harmful effects, what are the things we need to do? Okay, for does your family use LPG, kerosene, or both? Yes. And have you seen no smoking or emission check signages? Do you walk or cycle or take bus rather than individual car trips? So these all things do matter. So you should maintain the engines of the vehicles well, uh, to avoid incompletely burned fuel and all, producing more carbon monoxide and soot. So we should maintain the vehicle engines very well, and we should uh, get pollution under control check, and also we should plant trees and reduce the carbon dioxide emission. Combustion is essential to modern life for cooking, transport, electricity, but we cannot avoid it, right? So the goal is not to stop burning fuel, but to burn it more completely, more efficiently, and less wastefully. Okay, so here is the chapter summary. So what all we discussed today? We have discussed about combustion, types of combustion, fire triangle, then flame structure, fuels, and impact. Okay. So now let me ask you a few questions. If you have understood the concept well, you can answer. Shall I ask? Please go through the questions for quick recap. Which zone of candle flame is hottest? Yes, the outermost zone. Then write the balanced equation of magnesium burning in the air. Yes, it is Mg plus O2 gives rise to MgO, but you need to write a balanced equation. That means 2 Mg plus O2 gives rise to 2 MgO plus heat and light. Next, name the poisonous gas formed by incomplete combustion of fuels. Yes, it is carbon monoxide. Which type of fire extinguisher should never be used on an electric fire, and why? Yes, we should not use water type extinguishers because there is a risk for electric shock. Define ignition temperature in your own words. Yes, ignition temperature is the lowest temperature at which a substance catches fire and begins to burn and sustain combustion. Why is hydrogen used as a rocket fuel? Yes, hydrogen has extremely high calorific value per kilograms, and that is the reason it can be used as a fuel in rockets. So what are the key takeaways? Please go through the key takeaways. Combustion need three things, children. What are they? Fuel, air or oxygen, and heat. And what are the three zones of flame? Do you remember? And what is a calorific value? Burning fuel has the real cause. So carbon monoxide poisoning, acid rain, global warming, and all. So we need to reduce but use it wisely. So I was expecting you people to practice the flame structure diagram and fire triangle, and also you should be able to answer NCERT chapter 6 in text and end of the chapter questions you should be able to answer. Thank you.